Okay, I see Hash and George. Thank you. I think it's on the hour, so maybe we can get started. So thanks for everyone who's joined today's session. I'm sure there might be some more folks trickling in, but we can get started maybe with brief introductions. So I think today we wanted to talk a little bit about the observability pipeline, why that's relevant for the kind of use cases you have. So thank you for joining. I'll start off with a very brief, I guess, introduction about myself. We also have George and Hash from the Cribl team. So I head the security and analytics practice for Positka, been in the industry about 2 decades, done quite a lot of stuff, mainframe, .NET, Java, done a lot on security now. That's the focus. And I also have my colleagues over at Cribl. George, you want to sort of just give a very quick introduction about yourself?
Yeah, hi, good morning, good afternoon, everyone. So my name is George Mirhij. I'm the sales engineering manager at Cribl Emerging Markets and APAC. As you can see on the screen, I'm a cybersecurity person. I've been in the industry for more than 17, 18 years now. I come from Splunk, where I was heading the sales engineering team as well in the emerging markets.
Thank you. And we also have Hash as well on the call. So Hash will also be helping us with the Q&A session as we go through some of the queries. I'm sure that will come through. So thank you, Hash, for being here.
Pleasure.
Without further ado, let me just get started, I guess, with what we'll be going through today. So in terms of the agenda, one thing we wanted to talk about in the beginning was set the context about what do you mean by the data pipeline. And when we talk about the data pipeline, what are the kind of issues that teams face today in the IT world? So it could be infra teams, it could be DevOps teams, it could be security teams. There's a convergence, and there are a lot of common problems there. We also wanted to double click a little bit on Cribl there, because a lot of the challenges that we speak about today, Cribl aims quietly at being able to address some of those. So we'll talk a little bit about that. And then George will come in the second half to walk through some of the use cases, make it more real, so that you get to see how some of these practical applications come around in terms of the challenges and the problems you're looking to solve. And then, of course, we end up closing. In terms of hygiene, please feel free to ask questions. I think there's a chat box that's available. You can ask questions anytime. We can answer it as we go through, and then we'll also have a Q&A session at the end, of course. Talking about the data pipeline itself, now, when we talk about, I guess, something that's very common now, I keep hearing about questions such as, okay, what do we mean by observability? What do we mean by monitoring? Now, monitoring and observability are similar, but they are not quite the same. So monitoring is more focused, for example, on gathering a predefined set of metrics or logs. And what that tells you is whether the system is essentially up or down. So you're looking at, for example, is the server up, is the infra up and running, is there some slowness in the system? So there's a very narrow state of metrics. There's a narrow world you're looking at to figure out whether your system, your application, is it in trouble or not. Observability is actually something that's much broader in terms of the perspective it offers. So it is looking at a more holistic pattern in terms of what is happening in the system, what are the dependencies that are around. It does not have a very narrow remit in terms of what it tells you. So monitoring essentially, in summary, tells you that the system has failed, but it might not be able to tell you where it has failed. So that's where observability comes in, because it's going to help you filter through all the noise in your system. It's going to look at all the things that have been happening, both on the infra level, on the application level, on the dependency layer, and it's going to help you narrow down where the problem happened. So in a nutshell, I think that's what observability and monitoring are about. And in today's world, I think we are focusing more and more on observability. And observability has actually got multiple use cases, which I'll talk about a little bit in the next slide also. For example, one of the core use cases where there's an overlap is in terms of application performance monitoring. So without really being able to observe a system, you can't monitor its performance. So observability is important from the perspective of APM. If you look at site reliability, and if you look at infra monitoring, do I have network degradation? Is there issues with communication and then packets are dropping? So the SRE has a different perspective. He's looking more at making sure that your site is up and running, the performance is good. You need observability data to be able to perform SRE and infra monitoring. When you talk about end user experience again, when your customers log on to mobile apps, to websites, there's a lot of things going on in the back end. Are you making sure that your customers who are using your system, they are having a good experience? DevOps and SecOps now, of course, and now if you look at DevSecOps, which is merging both of these worlds together, unless you know what's happening to a low level of detail, you can't really do your function or perform your function capably. So underlying all of this is basically data, which is going to be the key theme in our discussion today. When you talk about the three pillars of observability, you will typically talk about three elements. You're going to talk about metrics. You might have CPU metrics, you might have disk usage, you might have memory usage. So those are numeric numbers that you can aggregate. So that's one element you need to be able to capture. In addition to that, when you're talking about distributed systems, very complex microservice environment where you have requests going all over your environment, you need to be able to do tracing. And finally, you need to be able to do logging as well. So there can be custom application logs, there can be server logs, there can be access logs. All of these together are actually what you want to be able to tap into. And to a large extent, the issue you have with the data also is that you have many data sources in your environment. So you might have, for example, data that's coming out over TCP UDP. You'll have metrics, events logs coming out through API calls. You'll have a lot of collection agents that are actually being deployed in the environment, and each vendor has something slightly different. You might have Splunk, you might have Datadog, you might have Azure in your environment, you might have Amazon Kinesis. It's a very complex environment where you are trying to collect all of this information. So one complexity is you are trying to pick up data from so many different, varied, disparate sources. The second part of your challenge now starts coming up on the observability side when you try to send it to different systems. Now, for example, if I'm more into IT infrastructure monitoring, I want to send it to my APM tools, I want to send it to my Nagios system. If I'm, for example, on the logging side, I might have Elastic, I might have some other systems where I want to route my logs to. If I'm doing APM, I want to pick up my metrics and traces and I want to send it to my APM system. So there is a lot that's going on. If you're on the security side, for example, particularly, you might have a whole load of SIEMs where you're routing data to or UBA system. So you have a vast number of sources and you have a vast number of destinations where you want to route the observability data to. And to some extent, today we'll be talking about how this causes challenges in the landscape of today's IT world. So yeah, that I guess leads me to segue into the challenges. But before I go there, any questions from anyone? So I think there's a question from Shweta about APM and observability. So I think a good question, Shweta. So I think, as I was mentioning earlier, the way I think I would think about APM and observability is that APM is a subset of observability to a large extent. So APM is more narrow, it's more focused on being able to tell you the state of an application and whether it's running the way it's supposed to be running. It's not going to tell you a lot about what's going underneath it in terms of the dependencies and the various interactions happening between it. So yeah, you might know that the service is down, the website is down, but difficult to find out why it's down. Observability data will help you to narrow down what happened and how do you sort of prevent it from happening again. So I think it's at the moment, today's world, I think it's very similar, but over time, I suspect you'll see that APM becomes more focused. Observability is going to be something that is going to be evolving over time. Shweta, I hope that answers your question. Okay. Moving on, I guess challenges that are faced by IT teams today. Now, we spoke about all of those data sources earlier. Now, here's an interesting statistic to just chew on a little bit. You are talking about close to 175 zettabytes of data that have been created and that will be created by 2025. So that's a massive amount of data to crawl through. In addition to that, you have a lot of compliance requirements that come to the fore. And then there's a cost of the data breach also that happens, right? So the overall cost that you have, it's starting to go into millions, billions of dollars, typically worldwide. And then, of course, the tooling and complexity. We looked at some of the sources, some of the destinations. The more tools you have, the more data you are picking up and routing to these different destinations, the more complexity you have in your organization. So all of these are causing challenges in the ecosystem. So what that translates to is, to some extent, what you see now in this diagrammatic representation, right? So you have so many different sources that get picked up. Now, you'll have any number of destinations that come out, and the way you route these data sources to their destinations is that you use multiple tools. So, for example, if you are a SIEM user, for example, or log management user, you might have Splunk in there. So you're sending your network data, you're sending your server data, your endpoint data, application data to Splunk, and then Splunk sending it again to Splunk, which is what it's meant for. But similarly, you'll have other things. You might have Datadog, you might have New Relic, you might have FluentD, you might have Elastic. So you are actually repeating the same process over and over again. So if you look at this layer, this is a complete mess at the moment. What happens here on your data collection side in particular is that your network team, your server team, your application team, they have to keep deploying, managing so many different agents. And then in terms of the consumers also, so each of these teams, the Splunk team, the FluentD team, the Beats, the Elastic team, everyone's going to give you a slightly different method of how you configure the data collection. So it is a very chaotic state of play right now. And then all of this traffic that's going through your system, you can imagine the kind of burden it puts on your infrastructure, especially in the network and communication side of things. So one problem that you can imagine, of course, is that the data is very voluminous, so it's cost prohibitive as a result. Vendor migration, you get tied into the vendor. So if you are using, for example, say Splunk now or Datadog now, you want to take away Datadog, you want to put in, say, New Relic next. This is a very big project to approve Datadog and put in New Relic. So you are tied into the vendor in today's day and world. If you want to sort of send filtered data to your destination, difficult to do. You want to do some enrichment, you want to do some kind of IP lookup, you want to do some data masking, very difficult to do because of the state of play that you have now. And then, of course, one more thing is that all of these systems, they cost a lot. So you are going to end up paying a lot in terms of the analytics firepower you're throwing at all of this data. Ultimately, I think because of this, from a IT management perspective, what happens is that if you look at the growth in data, the data is growing at an exponential rate at the moment. So it's going on, it's growing year on year, and there is no end in sight. But if you look at the IT budgets, the IT budgets are going to remain flat. So now the question is, how do you make up for this deficit where you have a lot of data, you have more and more data that you need to keep accumulating, pushing it to your systems of analysis, but your budgets are actually not growing. So to a large extent, from a management perspective, this is what most organizations are facing at the moment. And with that, I guess before I move on to Cribl itself and how it solves some of these challenges, I think there's also a poll that you had, right, because it
Yes, it's live now.
Yeah. So I think there's a small poll, I guess, going from the previous point. It's a short 10-15 second poll. So we saw some of the problems. It will be interesting to see how all of you on the call are seeing it in terms of where do you see your biggest pain point as right now. So we'll give it maybe about 10 seconds. I think you can follow the poll also, or I don't know if you can see the poll results, but we should be able to publish it in just a bit, in maybe another 5-10 seconds or so. Okay. I think we have about a little over half of our participants who have already answered. We'll give it a couple of seconds more and we should be able to end it now. I don't know. I'm assuming that folks are able to see the results on the screen now. So yeah, I mean, interesting, right? I mean, nothing too different from what I would have anticipated. I think it's actually fairly evenly split. So we are seeing that people are sending data to two new systems. They want to do complex transformations before they start using it. Filtering, maybe there's a little bit of that, and they want to archive also for long-term compliance and storage. So that's useful. Thank you for sharing that, everyone. And maybe I'll go back to the slides then. Let me just go on. Yeah. So now we spoke about a little bit of the challenges. I wanted to speak a little bit, I guess, about Cribl also. We have George and Harsh from the Cribl team as well, of course. So Cribl is essentially a disruptor, I would call it at the moment. So they are a hyper-growth company. They have backing from a number of very influential investors. So what Cribl is looking to do at the moment is they are looking to disrupt the value chain of the data pipeline. So in terms of being able to consolidate that entire journey from source to destination. And the way they want to do that is by giving organizations, by giving customers more choice and flexibility, so that there's no vendor locking, by giving control to the end users, be it the application team, the security team, so that you can sanitize data, you can transform data, you can choose what data to send to where, you can choose to remove data. And at the same time, we spoke about that gap between the data growth versus the deficit in the IT budget. So it aims to solve that also to some extent by saying that you can observe more data or more relevant data, but you can spend less because you can control what is the data you send to your destinations. So that is, I think, the primary ethos Cribl has as an organization. And if you look now at this diagram, so, and if you compare it to what we had seen earlier, so if you recollect, we had multiple sources, we had multiple destinations, but you had a bunch of intermediate processors, which is where your complexity was getting built out, right? So Cribl aims to simplify your entire data pipeline, and this presentation, I think, encapsulates exactly what's going to happen. So be it your network data, be it agents like Splunk or QRadar or Sumologic or whatever it might be it servers, endpoints, could be even streaming other streaming systems like say FluentD or Azure Stream Analytics. Cribl has its own agent as well, and then you have data lakes, right? So you have various ways of getting the data, but you get it into Cribl, and at that point, you have a single point of, you have a single fulcrum from where you can route it to multiple destinations. Now, what does this mean for you as a vendor, as a customer? So right now, for example, if you're on Datadog, and you're saying that, hey, I don't want to do Datadog, I want to take away Datadog, I want to put in some other APM system here. If the solution for you becomes as simple as you take out Datadog and you route the data to the new APM system that you have. Similarly, on the security side in particular, this becomes very relevant. If you have got any kind of SIEM here, for example, could be IBM, could be Splunk, could be Securonics, could be anything. Now you're saying that, look, I want to take away my current SIEM, I want to put in a new SIEM. It becomes, you're not touching your source at all. All you're doing is you're disconnecting one stream and you're just connecting to another stream. So it's a very simple picture, but it's a very powerful picture. And essentially, this is, I think, the core value proposition that Cribl is bringing to the data pipeline journey. If I talk about again the specific functionalities or use cases, and I think George will be showcasing some of this a little later. So one part of it is, of course, the vendor agnostic integration. So you're not reliant or you're not stuck on a particular vendor. You can collect information from any source. Once you collect the information, you can enrich it. Now, what do you mean by enrichment? You might have a custom lookup. You want to enrich using GeoIP. You might want to put in some location information based on the source IP. So all of those things can be done on the fly at scale. You might want to reduce. So this is where I guess the cost optimization comes in. So you have a high volume of network traffic that's coming in, but you want to look only at, say, for example, the accept traffic or the deny traffic. So you can control what you send to your end systems for analysis. You can transform the data. When I say transform, for example, if I am a bank, I've got my core banking system has got sensitive customer information in there, credit card information. I want to be able to hash it. I want to be able to encrypt and decrypt it. All of those things are actually possible here. So depending on where I want to do one-way transformation where I lose the data, which is more of a hashing function, yep, can do that. I want to retain the uniqueness. At the same time, I want to bring back my original data. So I want to encrypt and I want to decrypt. Yep, can do that also. And then when you talk about the routing part of it, of course, like I said, that's again, the collect and the route, that is the basic functionality that Cribl aims to service. And then finally, the replay part of it. So I want to send, I got a lot of data, but I want to make sure that I've got my full fidelity, non-modified data in a data archival tool of my choice. It could be MinIO, it could be Snowflake, it could be AWS S3, could be Azure Blob. I want to put it somewhere where I can access it later. Yep, you can put it there for long-term archival. You can play it back when you want. So to a large extent, I think these are some of the key elements that Cribl, these are the key services that Cribl provides. And then, like I said, I think George will be showing a lot of this to you as part of the demo. So I'm sure you'll have more questions at that point as well. Now, finally, we spoke about the functionality, we spoke about the use case, we spoke about the value proposition, but how does it help you? Where do you apply it? So if you're a security team, for example, if you're working on a SIEM migration project, typically you're ripping up your current environment, moving to a new environment. That's like a 3, 4, 6 month journey. In this case, if you're able to disaggregate the data collection part of it and the routing part of it, it accelerates your whole journey exponentially. If you want to work on compliance and data retention, yep, that's one more place where you can do it. You're moving towards, say, Snowflake. Cribl works very well with Snowflake, right? So you want to have a data lake strategy where it's easy to pull in data from anywhere, push it to some kind of a long-term archival like Snowflake or AWS, can do that, and any of these other projects, right? So there are many ways in which the use cases can be applied to the specific projects you might have going on. So with that, I guess I'll hand it over to George. But before that, maybe I'll just check if there are any questions there. Okay, yeah. There are actually a couple. That's okay. There's quite a few. Maybe I'll just pick up one and then I'll leave the rest for the Q&A session with Hash. Can't I just use one of my existing systems to simplify the pipeline? That is actually a good question, and that's a logical question to ask. I mean, for example, FluentD is something that I get asked about all the time. So FluentD is open source. Why can't I use FluentD? Problem becomes everything has its trade-offs. If you look at FluentD, for example, it needs a very engineering-heavy approach. You'll need to have a team dedicated to understanding, being able to manage the pipeline. It's not particularly user-friendly in terms of deploying it. It's not. It does not have the kind of integrations or the kind of transformations we want to do. If you compare that to something like, and then one more thing is because it's open source, it's not supported, of course. So if it goes down, who's there to help you? You can contrast that with something like Cribl, where it's more of a UI interface, which George will also demonstrate to you in just a little bit. It's very powerful, it's very flexible, and it's inherently scalable in the way it's architected itself. So compared to FluentD, for example, the time it takes you to go to market with FluentD and then maintaining it, it is a very, not to say it cannot be done, it is a very problematic and difficult scenario. Whereas for Cribl, it's a product that is supported by a product firm, and its whole aim, its focus is to make things easy to use. If you talk about something like Sumo Logic or anything else, for example, which is proprietary, problem is you get locked into Sumo Logic or you get locked into New Relic. They're not meant to really interoperate when you go into vendors, right? So again, that's got its own set of problems. So Cribl, I think it's got a very unique value proposition. Value proposition number one, vendor agnostic, don't particularly care where you pick it up from, who you send it to. That's proposition one. Number two is, in terms of usability, most times DevOps teams, SecOps teams, application teams don't want a headache of a complicated tool to use. It simplifies that whole experience of the data streaming part of it. So that's the reason I think Cribl has an edge, I would say, over a lot of these other solutions. Not to say you can't do it, I think it's just more difficult. I know we are also sort of starting to run out of time. So there are some other questions. Please do continue asking the questions. I think we have a Q&A session at the end of after the demo. But for the moment, maybe I'll hand it over to George. And George, if you don't mind taking it away.
Yeah, guys. So just quickly, keep the questions coming in the chat, and I will answer all of them one by one during the last session. Great questions, by the way.
Yeah. Sam, thank you so much. I'll spend around 20 minutes now on the demonstration. I'm sharing my screen. If you can't see it, please give me a hint. Apparently you can see it. So I'll start actually the demonstration with was the last question that has been asked or answered, which is around the agents and FluentD. Let me explain a little bit the concept of Cribl now that we move more into the technology. We've seen great, and we heard great insights from Sam around like the observability and the difference between observability and monitoring, as well as we heard a lot about like the challenges that you typically see when you're dealing with the growth of the data, which Sam has actually summarized them very well. One is around the complexity of managing this data, and second is about the cost of storing, managing and analyzing this data. So Cribl has been founded to solve these two problems mainly around the complexity and the cost of data. The concept on the technical side, if you want, because I'm aware we have many technical people on the call, is actually being able to connect to any source, process data in a very agnostic way is actually what you see in the middle here, and then route the data into one or more destination. And if I take the last question that has been asked or answered around FluentD, there is no issue in actually using FluentD if you have it, right? So as you can see here, FluentD is an example of a source for Cribl that we can read with it. But the focus is always on the agnostic and the centralized and the unified approach of data transformation. Because if you get from data from FluentD, for example, and then you have a Splunk universal forwarder that we can also read from, and then we have Syslog that we're getting data through for security and network devices. The challenge is, where do I do my data transformation and control? I can do it on agent number one, agent number two, device number one or number two, but Cribl offers me this unique, unified approach of data transformation within one GUI and a simple language without programming that I'm going to show you in a demo. So the concept is to connect these different sources that you see sample of them into sample or some of these destinations that you see on the right of the screen. Okay. The logic as the data flows in, and I'm going to show you in a demo just after this slide, the logic is actually to get the data in and then apply filters so that we can route data into specific pipelines. And the pipelines are actually the functions that will transform the data, that will apply all these use cases that Sam talked about, from masking into enrichment, into trimming the data and cleaning the data to reduce its volume, et cetera, et cetera. And then we send it to destination. So what you can see here is actually, we obviously transform the data based on the destination. So destination number one will need to take an optimized version in a CEF format, while destination number two will want a full fidelity data. In the poll that we ran before, I noticed few people answered the question with the need or the challenge that they have to archive full fidelity data. And this is a use case that we do in Cribl very, very well, for you to use this archived data when you need it in a very efficient way. And I'm going to demonstrate this as well in the demo. Again, feel free to shoot any question on the chat. And once we finish this section, we're going to answer the questions with the time that we have. Now, let me move into the demo now that I explained the concept a little bit. So this is the a live demo, an instance that I have on the cloud. Basically, it is receiving data from multiple sources and sending to multiple destinations, applying all the pipelines, the functions, etc., etc. What you see as a user is actually one single GUI, regardless of the number of data plane, the number of processing servers that you have, etc., etc. And remember what I highlighted before, the goal of Cribl is to smartly connect selected sources to selected destinations. And when we say smartly, means giving us the ability and the capability to actually filter and route data the way we want to route it. Okay, so for example, on this demo instance here, I have multiple sources that I configured 3 of them. So you can see here, there are different ways to collect the data from the sources. You can see multiple protocols and multiple technologies as well. So what you can see here is not only technology like Splunk or Elastic or Datadog, but it's also protocol-based through different ways. So there was one question in the chat around like SNMP traps. Yes, we receive SNMP traps. They are a source for us. So we can listen to SNMP traps. Similar way, we can listen to Syslog or any other protocol, and then we receive data or we go and fetch data, etc., etc. So what we try to do is to try to make it simple to connect sources to destinations. And if we look at the destinations, it's the same concept. We keep adding destinations to the technology so that you can connect to them easily. If you have Microsoft Sentinel, for example, Azure as a SIEM, you can send directly into this destination from Cribl. If you have Google Chronicle or Splunk or Datadog for APM, etc., we send the data directly into them after processing. So the beauty of it, if you think about it, is that we are able now with Cribl to connect one technology to another technology. So we're providing you this language that allows Elastic, for example, to talk to CrowdStrike. This has never happened in the past, if you want. Yes, there are some attempts to have like an agent from a technology sent to another technology. But in general, what we're providing here, again, to Sam's point, is this vendor agnostic approach, or this, we're a vendor at the end of the day, so we cannot say that we are purely agnostic, but we're agnostic from the analytics solution itself. We're agnostic from the SIEM solution itself. So you're not reliant anymore on a collection tier that is bound directly into a SIEM or a log management or analytics solution. So we are allowing actually Elastic agents, WinBeats, LogBeats, etc., to send data through Cribl into CrowdStrike, Logscale, for example. So the minute I configure this link between the two, now any data that I'm receiving from this source, the Elasticsearch agent through the API, is getting sent into CrowdStrike. And if you notice here, when I configure a link, let's say, for example, this link here between Splunk agent and, in this case, a Splunk destination, I have different options. I have the option to pass through the data, which means keep the data as is, just route it for me from this source into this or multiple destinations. Or I have the ability to actually apply my functions. So you can see here pipelines and packs, which are nearly the same thing. Pipelines, we create them ourselves. If you want, packs are like the concept of Apple Store or apps where they are created for you. And I'm going to show you a couple of examples on common data sources. So basically, if I go and apply a pipeline, that means I'm saying to the system, before you route data from source A to destination B, I want to apply specific functions. I want to apply, for example, a pack that will transform the data for me. Let's say, for example, I'm getting this data from a Windows server and I want to apply a pipeline. I can go and apply Windows event logs pipeline on the data. And we're going to see it. And I'm going to show you this in a demo. So if I go and connect this, and I say, for example, this is a Splunk forwarder where I'm getting Windows event data, I can go and apply the pack on this. And I can go and send to another destination from the same source, like, for example, to S3. Okay. Now, in S3, because I want to store full fidelity data, I pass it through. So notice with me here the difference between source number or destination number 1 and destination number 2, where I'm actually getting the data, but I'm replicating it with functions here. So I send an optimized copy of the data into Splunk, while I send a full fidelity raw copy into S3, into this storage. And then the same thing happens for the other sources, etc., etc. I noticed that there are some questions, but I'll keep all the questions or the answers for the end. I'll still spend like 10 minutes, and then we'll move into the questions and the answers. So keep like good amount of time for it. So now I connected the sources into destinations. And think about it. Tomorrow, Sam talked about like the migration. Migration is a very cumbersome project by itself usually, because it's not about only bringing data into this new tool and running the reports. It's more about like the most important thing specifically in security is the data. We don't want to lose data as we migrate into another solution, probably for compliance or many other reasons. So with Cribl, what you're able to do now is actually say you want to migrate from, I don't know, Splunk into Elastic, or from Elastic into QRadar, etc., etc. Now what you can do is you can go and create a new destination. Like, for example, I'm talking to many customers today that they are looking at the Amazon and new security data lake. So as you can see here, it became already a destination for us. So we can send directly data in the OCSF format to the Amazon security data lake. And then you can migrate, you can send 2 copies of the data in different formats and then decommission the first one once you are ready. Now let's move into something that is more interesting. We routed the data into the destination, but how do we optimize? How do we achieve this control and this reduction on the data so that we can save on the storage, we can save on the computing, and we can save on the licensing of the SIEM and IT operation technologies? So I'll take here a couple of examples that are ready-made. You noticed when I connected Splunk Universal Forwarder into the SIEM, I used a pack that is called, in this case, Splunk Forwarder Windows event. What this pack will do for me, it is already ready-made, as you can see here. It will apply a series of functions depending on the data. So if I'm getting classic data and I want to send it into Splunk, before I send it into this destination, I can apply all these functions that you can see here that you don't really have to touch. So those functions are created, packaged for you in what you can see here as a Cribl Splunk Windows pack. And then what they will do for me is they will optimize the data. What do we mean by optimize? There are different ways. Obviously, we don't have time to go into each and every one of them. But basically, I'll take a couple of examples. If you look with me at the Windows security events on the screen here in blue, you notice there are, I'm sure most of you are familiar with this type of data. So there is a lot of good information in this data. But the problem is the data is not very well written to be optimized. So it consumes a lot of storage for no reason. It consumes a lot of license volume for no reason. That's because it has a lot of what we call white spaces. It has a lot of null values or non-existent values. Our job in Cribl, in this case, is actually to optimize this format without losing on the visibility. That's the most important thing, without losing on the fidelity that I have with the data. So the minute I apply my pipeline into this data, notice with me what's going to happen here. I'm going to zoom in, and then basically it will show me how the data will go out of the pipeline. And notice here, it transformed the data from a classic security bulky event into something that looks like this in a JSON format, where I basically took all the field and values that I need, and then I removed the things that are useless, basically. And with that, I was able to reduce, this with me here, we are able to reduce this bulky event by 71%, which means that I reduced the load on my SIEM or log management by 71%, including the storage. The same thing, just running quickly because we don't have much time. I have only 5 minutes remaining. The same thing here applies to other data sources as well. So in case of Palo Alto firewall or Fortinet firewall or ASA or checkpoint, etc., we have created those packs as well that, as you can see, they apply the same methodology, which is take data, let's say, for example, Palo Alto traffic, and apply set of functions that will allow me to clean this data. So in case of Palo Alto, you can see there is a lot of repetitive fields in this case. So we're not going to change the format of the log, but if you zoom in with me, you will see there are a lot of repetitive events, like, for example, the time that you can see here, and then you can see here the same one, and then you can see in here and multiple times. Logging is not optimized by the source itself. So our job is to take this log. As you can see here, we color code the changes and remove all the redundancies and the non-useful information, and then we reduce with this the data. Now, say, for example, with me, okay, I reduce the data, but I have some sensitive fields that I want to mask before I send into multiple destinations or before they go out of my network, for example. Let's say I'm doing the logging on the cloud. So we can apply a function that is called mask, just as an example. And this masking function will allow me to mask the data in the GUI, okay, without using any configuration files or any coding. And then basically I tell it which field I want to mask. And in this case, I'm doing it on Palo Alto, although it's not a very confidential, I would say, field and value. But just in the interest of time, I say to the system, mask for me the field source, for example, or mask for me the field index, for example. So basically, when I do this, I'm saying to the system, take this field and mask for me the value of this field, okay? And as you can see here, it hashed for me this value. Obviously, we usually don't mask the index, but any sensitive field like a credit card, username, etc., I can mask it in a very easy way. Okay. With that, I remain only with one single use case for today before we open it up for questions and answers. Now, before I go into the last use case, notice here with me on the system, everything that I've done, any action that I do is actually monitored here. Now, okay, that's not rocket science, it's easy. But what I want to highlight is on the system, we have Git, and Git governs every single, so the Git framework governs every single change on the system, because here we're dealing with data, potentially data going to multiple destinations used by multiple departments. So we have designed the system ground up from day zero to actually have visibility and control on who's changing what. And then the Git that is embedded in the system will allow me, before I go ahead and commit or decommit, I can go and see the changes that have happened on the system. I know this is very technical for today, but I wanted to highlight this because this is extremely important as you deal with data that is going to be used by multiple departments and multiple systems. Okay, so I can visualize and monitor everything that is happening here. Now, moving into the last use case for today, I'm going to talk about this case of storing full fidelity data on a storage on a system. And here, I know that there was a question around, like, do we use our storage, like storage from Cribl, or we provide any storage? The answer is no. So what I'm going to show you here is actually the ability to leverage a third-party low-cost storage to store your data, okay? To store your data in full fidelity copy, to store your data for long period of time, for compliance, etc., etc. But what is the trick here? Why it is very valuable in Cribl? It's simply because if you go with me and look at what we've done in the beginning, we sent a full fidelity copy pass-through from Splunk agent or from Syslog or whatever into S3. So I'm sending raw copies. and I store them there. S3 is very cheap compared to the normal storage. I store the data there, and I'm passing it through. But the important piece is, how can I retrieve this data once I need it? Do I need to do a project by itself to onboard this data again? Or I have an easy way to onboard this data? The answer is, of course, we make it easy to re-onboard the data that we need only, that we have stored. So how do I onboard this data? Is by basically going back into the sources and collect the data selectively from S3. Okay, so in this case, we have an S3 configured, where basically I configured the S3 to write the data as you saw before. Now I can go back and tell the system, replay back the data for me. Let me find the data and send it into Elastic or Splunk or QRadar or Datadog. Now the trick here is that when we stored the data, we stored it in a very structured way. We said, store the data in a folder called source, and the source is the source of the data that we got, and then store it in another folder called year, month, day, hour, host, source type. That allows me actually to go and search the data without opening the buckets on S3. Without opening the buckets, I'm able to find the data that I want simply because I know how I stored the data at the beginning. And that's the magic, that's the trick here. So for example, if I want to go and collect some data, I can say to the system, you know what, onboard for me back the data from the 1st of June until today, get me all the data, but only in this time zone. The beauty here is that I can preview the data, search it on the S3 before collecting it back. So I go and say to the system, run it for me. And then basically when I run, let me do another one, for example, this one. When I run the data, output test does not exist. Oh, okay, so let me just remove this commit here because we did some changes. And then basically if I go back to my source and I tell it, onboard for me back this data that I needed. Yeah, I don't know why it's not getting back the data, but in any case, it's basically allows me to replay back all the data that I can, or that I can find here on the system. Yeah, it's I think it's something that I configured from before. Maybe something here, I don't know. But in any case, it allows me to actually replay back the data that I can see on S3. So for example, all the data that you can see here live going into S3, because I'm sending it in a fidelity, full fidelity copy, I can go and fetch the data back from the S3 that I got it. I'm gonna try to fix this, but in the meantime, I'll stop here and open it for questions.
Thank you, Sam, and thank you, George, for setting the foundations for the platform. Really appreciate it. What I'm going to do, I'm going to go through the questions on the chat in sequential order, right? And obviously, feel free to ask me any more. Absolutely, we support.
Can I interrupt you?
Yeah.
Sorry, because
please.
I know.
Yeah,
so please. I just found, for the people who were following me on the replay. So basically, I was sending to test that doesn't exist anymore. So let's say I want to send to DevNull or to Splunk or whatever, and then basically when I do this, I can go and replay back the data like I was showing before. So I was showing I want to find the data before replaying it back, basically from 1 month. I go and run, and then basically, as you can see here, it searched for me the data. Notice it's passed through because we passed it through as is to S3, and then it searched for me the data on the disk. This data is still on S3. Now I can go and say, you know what, run it for me a full run, which means take it and send it into the destination, which is Splunk. Sorry to interrupt you, but I just wanted to make sure that people are following me on this one. Back to you, Hash.
Yeah, no, that's actually a really good point. There was a very good question on replay, actually. Okay, here we go. This is from Robert Roy. How do we ensure there is no data loss while filtering? This is a great question. We operate in highly secured environments where chain of custody is critical, right? So the same event needs to be persisted in the same format. And it's similar to what George showed for S3, which is why I'm answering the question first, because we can get the data verbatim and pass it through into S3 untouched, right? We can touch it if you want, but it's untouched. So if you hash the two, the hashes will be exactly the same. So that's how we ensure the integrity of the raw event. Now, if you're running in a SOC, I don't know how many people are in the security domain. What most SOCs are now starting to do is to keep one copy verbatim as is, and then keep another or manipulate that copy and send it to their SIEM of choice. The SIEM doesn't need 50 fields. It probably needs 10 of them. So why am I keeping the other 40? This is the best of both worlds. Why? Well, you can run your alerts, dashboards, and reports in your SIEM as is at a much lower cost. However, if you need to run a compliance report from data 4 years ago, you can just query, like George showed you, the S3 buckets, right? So you get lower cost with full fidelity. Okay, so hopefully that answers your question. By the way, if you need some more clarification, just jump in, unmute and jump in. I've got no problems. The next one was SNMP. Yes, it is supported. I believe it's version 3 that is supported. George, keep me honest there. Yeah. Yeah. So we can receive SNMP traps, so we can act as the receiver, but we can also issue SNMP traps as well, right? So it's kind of a bi-directional capability we have there. Similar thing with Syslog. I'm pretty sure a lot of your environments have very complex syslogging infrastructures. I'll give you a funny story of a large bank in the US, a very large bank actually, 400 terabytes of syslog environment. There was a 60-year-old guy. He walks into the office and resigns, right? And then they realize he's the only guy who knows anything to do with Syslog, right, for the entire bank. So then they brought Cribl in. We repurposed all of the Syslog rules within about 2 months, and now the entire syslogging infrastructure has been transferred over to Cribl with a bunch of other benefits, right? So yes, we can receive Syslog, but we can also issue Syslog as well. So that's the Syslog question. There was a very good question on, here we go. This is by Kishore. Is this not very similar to a pub sub architecture? We get this all the time. There is a very, very fine nuance between Kafka and what we do. Kafka is a messaging bus, which means the destination subscribes to the feed. We don't care about the destination. We just send it to them, right? So we're a routing engine and Kafka is a messaging bus, right? And in the security domain, which is where we probably play 90% of our technology, where it pays the best. In the security domain, it is all about routing, right? The SIEM is not subscribing to anything, it's getting the data, right? And that's the first thing. The second thing is performance, right? If you're running in a pub sub environment, there is a bunch of logic that determines whether you get the data or not. With Cribl, because there is no logic on the destination, it's a lot quicker, right? So we can process petabytes of data. Actually, internally, we are bench tested at 4 peta per day, right? That is what our platform can handle. And that's what we internally test at, right? 4 peta per day. So hopefully, and that's the key differentiator. So you asked me what the key differentiator was. We're a routing engine, and obviously everyone else is a messaging engine.
I just want to highlight one thing. This is a very important topic. Obviously, we cannot cover it a lot in this session, but there is, as Hash mentioned, some overlap between the two, but practically, especially in the cybersecurity projects, We see many Kafka customers, whether they are using the open source Kafka or the commercialized versions of Kafka, coming to us for these things around integration, scalability, and this kind of use cases. And guess what? Kafka is actually a source and a destination for us. That's what I wanted to highlight. You can configure Kafka to be a source for Cribl, so we can read from Kafka or we can send into Kafka. Okay. Yeah. Next one.
Yeah. No. Yeah. So that's a really, really good point. So there's very specific use cases. I mean, our best customers are the ones who have tried to do the data wrangling in Kafka or Confluent, and they come to us because of performance, right? I mean, the hardware footprint that you need to run the same Cribl environment within Stream is a lot less, right? Arun, how does licensing work? Licensing is very simple, right? Well, firstly, we have 3 products, right? 3 types of licenses, I should say. First is free. What my advice to all of you, Cribl is well. Let me start by telling you a little bit about Cribl. Here we go. There you go. Thanks, George. So the first thing about Cribl is we are growing at exponential rate, right? So we need an ecosystem, and every one of you on this call can be part of this ecosystem. Our CEOs, one of the CEO's core pillars is free education. So if you go to Cribl University, you can get trained and certified on all of the technology that's been discussed on the webinar today. It's free. Get certified. There's a big market for these skills. So I strongly advise that you have a look at it. And by the way, it's not a heavy lift. It'll probably take you 2 days to go through it, right? So that's the first thing. The second thing is about the licensing. We have 3 tiers of licensing. First one is free, right? So you can go to our cloud offering, sign in with Google. You don't even have to register. Sign in with Google, and you get the full capability, minus a couple of key requirements like LDAP and worker groups. You can see that on our website. The second one is standard, right? That is, once again, locked to a certain degree, but it's supported. So typically, if you're in a production environment, you don't want to be running with free software. So that is a paid for, but a lower cost version with limited functionality. Our enterprise version is fully unlocked, right? Those are the 3 tiers. How is it licensed? It is licensed in a very simple metric, and I'll explain it to you. On the amount of raw, uncompressed data ingested within a 24-hour period. So if your bank or telco or whoever you work for ingests 10 terabytes a day, that is what the license you need. Now, you can re-ingest that data for free. So as long as it passes the Cribl engine once, if an event passes the Cribl engine once and it comes back through Cribl, you won't be metered on it. And this is important for the capability that George demonstrated on S3, right? So hopefully that answers your question on licensing. The other one was, can Cribl store data as well, and how is it managed for aging? This is, another very good question. If you're running a platform like Splunk, you might have different buckets for retention. You might have a 3-month bucket. You might have a 1-year bucket, and you might have an indefinite bucket, right? What Cribl can do is actually tag events and then route it to the right index within Splunk, right? So it sees an event. Okay, this is like for my forensic investigation. I'll keep this for indefinite, right? This is a firewall rule, firewall alert. I'm going to keep it for 3 months. So we can actually tag these events. So hopefully that answers the question on how we manage aging, right? The one thing, I think George touched on it, but I'll just reiterate. If you look at the S3 capability, it's very cool because not only can we search it, right, like you would search, any other platform, you can do it without Cribl, right? So you can actually go into, it's not proprietary, right? So you can actually go into the S3 bucket. You can actually search manually. There's no proprietary indexes or anything on that. If you want, you can go and use another provider. We're completely open in that respect. We don't lock you in, is the point. And this is the whole point of the product, right? We don't lock you in, right? What else is there?
You can see here we stored them in buckets in a very structured way. So those files, you can read them with any other like S3 Explorer or anything like that. The data is inside these buckets. You can discover it on Cribl, and it points you to the data.
I didn't realize we're over time, but I'll answer one more question. Thank you everyone for staying another minute. How difficult is Cribl to set up? Great question from Kumresh. I'm not even joking. It's literally 5 minutes if you use our cloud product. If you use our downloadable product, it's probably going to take you about half an hour, right? So the whole product has been built from what we call first principles, right? So we have looked at the entire pipelining process, dissected it, and made it super simple, right? So if you go through our training or even our sandboxes, you don't even have to do the full training. You could probably get, dangerous within half a day. And then you can go and either go to our cloud product or download the product for free. And you could get up and running in a very short period of time. Thank you, George. This is great. Yeah. So these are take a screenshot of this, right? Take a screenshot, take a picture of it. And, these are all of the assets you will need to be successful and drive some real impact within your company on saving costs and getting efficiencies from your core toolkit. So that's all I have. I know we're over. I don't want to talk. Sam, I'll hand it over to you.
Yeah, thanks for that, Hash. And I know we are over time. So some of the slides that you shared, George, we'll make sure that all those slides make their way out to the folks here also. So in terms of next steps, thank you for, first, I guess, thanks are in order. Thank you for your time. We'll share the slides with you. In case anyone wants a more customized demo, they want to talk a little bit more, please do reach out to us. But again, thank you for your time and look forward to engaging with you again shortly. Thank you, George and Hash, for your time on today's session as well.
Thank you, everyone. Thank you. Bye-bye.
Bye-bye.